So in assignment number 5, we're going to be talking about synthetic division, not just long division, and how we can use the remainder theorem to evaluate expressions in a little bit quicker way. So let's go ahead and get started here. Let's just practice long division here first. We have this equation, which is 5x to the third minus 6x squared plus 4x minus 1. And we're going to divide that by x minus 3. So I'm going to start by asking myself, what do I multiply x by to get 5x to the third? And that is 5x squared. So 5x squared times negative 3 is negative 15x squared. 5x squared times x is 5x to the third. So when I subtract, my 5x to the thirds cancel. And negative 6 minus a negative 15 is positive 9x squared. And then I'm going to bring down my 4x. So then I'm going to ask myself, what do I multiply x by to get 9x squared? And that's 9x. So 9x times negative 3 is negative 27x. And 9x times x is 9x squared. When I subtract, my leading terms cancel. 4x minus a negative 27x is 31x. I'm going to bring down my negative 1. So I'm going to ask myself, what do I multiply x by to get 31x? And that's 31. And so 31 times negative 3 is negative 93. And 31 times x is 31x. So my leading terms cancel. But negative 1 minus a negative 93 is a positive 92. And so this would be 5x squared plus 9x plus 31, remainder 92. So this is a different way of doing that I want to show you and that we're going to learn today using a process called synthetic division. And it's going to look something like this. I have my first coefficient, which is 5. My next coefficient of x squared is negative 6. And then I have a positive 4 and a negative 1. These are all of my coefficients that I have in the term that I'm dividing by. But then I'm going to put here in this little box here a positive 3. Because I'm dividing by x minus 3, my solution, if this were a factor and I set it equal to 0, my solution would be that x is equal to positive 3. So I'm going to put a positive 3 here. And then all I'm going to do is simply add and multiply. I'm going to add 5 plus, there's nothing here. So 5 plus 0 is 5. I'm going to multiply that times 3, which is 15. Then I'm going to add negative 6 plus 15. Well, that's positive 9. I'm going to multiply it times 3, which is 27. And then I'm going to add 4 plus 27 is 31. I'm going to multiply times 3. 31 times 3 is 93. And then I'm going to add negative 1 plus 93 is 92. If you use that process, the last number you get here is always your remainder. You can see that here. Those are the same. And then these three numbers here are the coefficients of these three numbers. So I have my constant term, my linear term, my quadratic term. My final answer, if I divide, is going to be 5x squared plus 9x plus 31, remainder 92. And that's the exact same thing that I did here when I used long division. There are a couple things about synthetic division that are nice. It seems to be a lot easier to go through this process to make that division happen. The one thing that doesn't work is you can't use synthetic division if I had a coefficient in front of the x in what I'm dividing by. So if this was, let's say, 2x minus 3, then I could not use synthetic division. The only way I could use synthetic division is if this x here is by itself. And then the number that I always put here would be the 0. So if it's x minus 3, I put a 3 here. If this was x plus 5, I would put a negative 5 here to go through my division process. And this process is called synthetic division. We're going to talk more about this in class. But let's go ahead and take a look at this next problem. A sarcophagus is an old cement tomb from Egypt. And let's say that we have a sarcophagus that has a volume that it could be expressed by that expression. And we know that the length is x plus 4. And so let's say it's a rectangular sarcophagus. And so that means it has the length, the volume is the length times the width times the height. So if the volume is the length times the width times the height, and I know that the length already is x plus 4, I want to find the other factors here. What I want to do is write the volume instead of x to the third minus 13x plus 12. I want to write the volume as the length times the width times the height. And so I already know that the length is x plus 4. So what I want to do is find the other dimensions here. And so to find what the other factor would be of this polynomial, I'm going to have to divide. I'm going to take 1x to the third plus 0x squareds, a negative 13x, and a positive 12. And I'm going to use synthetic division here. I'm going to put a negative 4 here, because if I were to solve this factor here, if I set it equal to 0 and solved it, I would get that x is negative 4. And so if I use synthetic division, I'm going to start by adding 1 plus nothing here. So 1 plus 0 is 1, but I'm going to multiply it times negative 4. Notice I put a 0 here because there isn't an x squared term, so I need a place there. 0 plus negative 4 is negative 4. I'm going to take negative 4 times negative 4, which is positive 16. Negative 13 plus 16 is positive 3. If I multiply that times negative 4, I get negative 12. Negative 12 plus 12 is 0, and you can see my remainder is 0, which is good because that means that x plus 4 really is a factor. Then I'm going to take this right here. My other factor would be x squared minus 4x plus 3. And so that would be my other factor, but I want to write that as two factors. And so I'm going to take this and factor that expression. So if I factor this expression, I will have x times x. Let me just do it over here. I will have x times x Okay, so I will have, let me try this again here. I'll factor it here. I'll have x times x, because that gives me x squared. And then I want something that multiplies together to give me 3 that adds to a negative 4, like a negative 3 and a negative 1. And negative 3 times negative 1 does give me 3. A negative 3x and a negative 1x does give me a negative 4x. So what are the other dimensions? Well, they're x minus 3 and x minus 1. So it says here, if the length is x plus 4, find the other dimensions. Well, the other dimensions are x minus 3 and x minus 1. So I don't know if you can read this. It says the actual length is 10. So if the actual length is 10, that means that x plus 4, well, that's 10. Well, if x plus 4 is 10, what does x have to be? Well, we can solve that equation. We could go x plus 4 equals 10, subtract 4 from both sides, and we know that x has to be 6. So what do the other dimensions have to be? Well, we know that the first one is 10. If x is 6, then 6 minus 3 is 3. And if x is 6, then 6 minus 1 is 5. So the other dimensions are 10 by 3 by 5. Let's move on and take a look at a different situation. Here we have f of x equals x to the fourth minus 5x squared plus 4x plus 12. What I would want you to do is find f of negative 4. So you can plug in negative 4, take negative 4 to the fourth minus 5x minus 5 times negative 4 squared plus 4 times negative 4 plus 12. There is a shorter way to do this though. Once you figure that out, we could use synthetic division. I would have a 1 here. I don't have an x to the third, so that's 0. This is negative 5. This is 4. And this is 12. And I'm going to put negative 4 here. So if I go through this process, I'd have a 1. 1 times negative 4 is negative 4. If I add them together, I get negative 4. Negative 4 times negative 4 is 16. If I add those together, I get positive 11. 11 times negative 4 is negative 44. If I add those together, I get negative 40. Negative 4 times negative 40 is negative 160. And negative 160 plus 12 is negative 148. Although I made a mistake, because negative 4 times negative 40 is positive 160. So when I add these together, 12 plus 160 is going to be 172. And if you noticed, when you plug negative 4 into this expression, it equals 172. Well, why does this work? It's a good question. The remainder will always give you what that expression is equal to. And so what we want to do here is figure out why that works. Well, first of all, I want to show you this. If I take this expression here, 35 divided by 4, I'm going to get 8 remainder 3. Well, I can write it like this. I can also write it like this. 4 times 8, take these two things here, 4 times 8, add the remainder, and I will always get what I started with. So if I use that same logic, I took this, I divided it by x plus 4, and I got a remainder of, I got this answer with a remainder of 172. In other words, I can write it like this. I can take what I'm dividing by, which was x plus 4. I can multiply that times my answer. Here my answer was 8. I can multiply that times my answer here, which is going to be x to the third minus 4x squared plus 11x minus 40. Just like I did here and here, I can add my remainder, which is 172, and that always gives me what I started with, which is x to the fourth minus 5x squared plus 4x plus 12. That means whatever I plug in here, I'm going to get the same answer if I plug it in here, because those two things are equal to each other. Well, if I plug negative 4 into the expression on the left, this is going to give me a 0, which means this product will always be 0, and I will have 0 plus 172, which is just 172. That'll always be my answer. And I will always have a 0, because if I plug in negative 4, then if I plug in negative 4, this is my solution. My factor would always be x plus 4. And so that means if this is 172, this will also be 172 if I plug in the same number. So this is called the remainder theorem. And basically, just to recap what it means, this is, you really don't need to understand this completely. I want you to know why it works. But what you really need to know is that if I want to find f of negative 4, I could plug negative 4 into all the x's and evaluate it. Or I could use synthetic division by plugging negative 4 in here and get my remainder, and my answer is always going to match what I would get if I plug negative 4 into this expression. If I wanted to find out what f of 5 was, I could do the same thing. I could plug 5 in here, or I could plug 5 in here, use synthetic division, and whatever my remainder is would be my solution. So this is what we're going to be doing on our homework assignment for tonight. Good luck with it, and we will talk more about it tomorrow in class.